Good morning, everyone. This is your Bicolana Math Nuna signing in. Well, not many people are lucky in love, just like this boy and girl in this math problem. It made me curious as to how the solution is. I tried to look it up online. I couldn't see any work about it. I found this math problem, which is also about related rates, and I tried to pattern a word problem from both of these. I put their ideas together. And so I came up with this word problem. And I'm going to show you right now how to solve it. I'm going to use derivatives using implicit differentiation. So here you go. I'm going to start by doing some annotations using my Wacom tablet here. So the girl and the boy are standing 5 feet apart. The boy is due north, and he's running at a rate of 5 feet per second. He's really hurt. He's already running away. The girl is going down south, and she's just walking, so hurt, so forlorn, but still calm. And her rate is 1 foot per second. The question is, how fast are they separating from each other 5 seconds after they started moving to a new life without each other? Pretty dramatic. That's life. Sad sometimes, but we have to move on. So let's see how this can be solved. So I'm gonna start by creating a diagram. So this is where the boy's at. This is where the girl's gonna be at. They are 5 feet apart. The boy is heading north. The distance he traveled, we will label it as X. The girl is heading south, and we will label the distance she traveled as Y. The change in X, which is the change in the direction with regards to time, we're going to label it as dx over dt, and that is 5 feet per second. The change in the y direction, which we will label as dy over dt, is 1 foot per second. And the question that says how fast they are separating is actually looking for the change in distance with respect to time. So dz over dt is the one that we're looking for. Okay? If you will look at this part, I'm going to use a blue color here. This distance, which I will mark as Z, is actually the hypotenuse is gonna form a right triangle. If I'm going to copy this Y over here, and this same horizontal, I'm gonna put down here. You could see the right triangle, and we could actually apply the Pythagorean theorem in order to solve for the letter Z, which we would need later. I'm going to recreate the triangle right here. So as you see earlier, this was 5 feet. The X and the Y is together now on this side, so I will label it X plus Y. And this side, oops, sorry, let me use the eraser. So hard to control the pen actually. I could use a triangle here, but I'm choosing to use the pen. Okay, so this is the Z. Okay, so we're going to write an equation now that relates all of this. So we can write it as 5 squared, remember the Pythagorean theorem, plus X plus Y squared equals Z squared. I hope you remember the Pythagorean theorem, which relates the 3 sides of the right triangle as A squared plus B squared equals C squared, right? Where this letter C represents the hypotenuse, or that side opposite the right angle, and the A and the B are the 2 legs right here. Okay, so we're going to apply now implicit differentiation in order to find our unknown. So this is a constant, so its derivative will definitely become a 0, so there's no need to write it down. We're gonna use implicit differentiation for this expression, and it's gonna become 2 times X plus Y. This exponent here comes down as a vector. And then we're going to get the derivative of the terms inside. So the derivative of X is 1, and that's going to be dx over dt, the derivative of X with respect to time. And for Y, it's going to be 1 times dy dt equals, implicit differentiation also on the right side is going to result in 2z dz over dt. So since we're solving for dz over dt, we need to isolate that. It's just like when you're solving for simple equation for x, for example, you need to isolate the variable x. We need to do the same thing right here. So since we need dz over dt here, I will divide both sides by 2z, so it could be eliminated on the right side. So let me use a different color pen to show my division. So divided by 2z, divide all throughout by 2z. So that would cancel off the 2z right here and this number 2 here on the left side. So here on the left, we have x plus y, and we don't have to write the number 1, so that's going to be dx dt plus dy dt. Solving this is so madugo, so bloody, especially if you already forgot your calculus when you were in high school or college. Okay, so let me move it down a little bit, up. Let me continue. Okay, we still have the letter Z left behind right there. Oops, the pen is controlling itself. Oh, it's messing up my work. What happened there? Let me erase. Good thing it's just a pen and it's erasable. Thank goodness. Okay, so it was x plus y right here. Okay. See, sometimes you mess up in life, but you persevere. You still continue. Life moves on. Okay. So, you notice here that you have the z variable, but we don't know what z is yet. But we can solve for what x and y, and then use it to find letter z. If you go back to this part, which I said x represents the distance that the boy traveled, and from looking through the problem again, doing a back read, you will see that it was 5 seconds after they started moving to a new life. So from noontime and then 5 seconds after that. And then it says here 5 feet per second. It means that the boy, if you're going to compute for x, that's 5 feet for each second in 5 seconds. That's going to be 5 times 5. So that distance is actually 25 feet. And then for the girl, that's 1 foot per second. For 5 seconds, that's going to be 5 feet. So that is 25 feet and 5 feet. If you're gonna add it for this vertical side, that's actually going to be 30 feet. So this side is 30 feet. This side is letter C. We're looking for that. And this side is 5 feet. They were 5 feet apart. And so you will be solving for Z by squaring 30, squaring 5, and that equals Z squared. So this is 900 plus 25